Hi, Martin.
Hello,
How are you
how
doing
are
today?
you?
Not too bad. What about you?
I'm pretty good. Yeah.
Nice. Let's see if we figure out the execution today.
Yeah, that's going to be a tough subject, but unfortunately we have like a whole 15 minutes to discuss it. So,
I thought I will do the same as with satisfiability.
yep.
Hi, Sachin. Hi, Camille.
Hi guys.
Hey, hello. Hey.
Michael got the
Hello.
recording lights on.
Fun?
You got the recording lights on,
Yeah.
but the wrong mic. You sound far, far away. Or your mic could also physically be far, far away.
Is it? Oh,
Oh, now you have to
That's
raise.
that's better. Yeah.
better? Oh,
What?
no, I had another meeting also on Zoom. Nobody complained.
Well, you had AirPods in your ear, so
I have AirPods in my ear.
yeah. But that means that the audio usually sucks. They're so bad at noise canceling. Like they're great at noise canceling for your own ears, but when you sit in a coffee shop or you sit at the airport and you try to do a call, you actually hear everyone around you better than yourself.
I'm really looking forward to the AI summary. The participants discussed the audio quality of the AirPod.
Let me get ready.
First 5 minutes are always just chatting, isn't
Okay, agenda filled up. We have a bit more than 3 people. Share.
it? Hi, Jane.
Hello.
Kamal has new plans.
Oh, I have a lot actually.
Oh, wow.
It's like
I envy your Monstera. Mine is dying.
I don't water them. Sorry, it's not my responsibility.
Oh, I believe I'm dying because I overwatered it. Probably has root rot or something like this. Okay, Steven is also
Okay. Yeah, we are complete.
complete.
Okay, let's start.
I
So let me get us started by first reminding you of the Graph Spec membership agreements that we all agree to follow and the GraphQL code of conduct. All these agreements are listed out in the agenda, so if you need a refresher, take a look. I also need to remind everyone that we are recording or that the AI is taking notes. So if you're not agreeing with that, you have to leave the meeting. And otherwise, let's start with a quick round of introductions. So I'm Michael, I'm the host today.
Hey, Shane from Apollo.
I'm Pascal from Chili Cream.
I'm Sachin from Apollo.
Camille from the guild.
Hi, I'm Steven of Netflix.
Martin from Apollo.
So Pascal has very bravely just put in execution as an agenda item. Just as a reminder, we discussed for the last couple of weeks satisfiability and to see like how we finish that out, like the plan options algorithm and so forth. We wanted to have a discussion on execution and at least see if we have two separate things there or if we can share things like plan options with some algorithmic stuff we come up with around execution. Does that sound right?
Yep.
Sounds good.
Awesome. Okay, Pascal, do you want to
Well,
introduce?
so I think the discussions that we had in the very early satisfiability phase were super helpful in trying to figure out how we want to specify execution satisfiability, and I believe we should do the same thing for execution. Last time we were talking about the plan options thing and how we want to specify execution and whatnot. So I hope everyone has made up their mind. So we can do a quick round. If you have something to add, just say it. And if it's already covered, then you also don't have to repeat what others have said. So generally about the scope first, about the scope of how we want to specify execution. Discussion last time was a bit, how should we specify it, and in what detail? And my hope personally is that we find something as elegant as the satisfiability algorithm, which doesn't represent like a full, actually production-ready implementation of it, but at least covers the concept of how the execution happens, when a lookup is executed, how the fields are merged, and all of these things. So my hope actually is that we don't get a production-ready algorithm, but we at least get an algorithm that covers how the execution should be done. Because I believe without this, I mean, I think this is an integral part of the specification, that we describe how we are actually gonna execute what we have specified. I don't know, does anyone have other opinions that they want to throw in? No opinions. Great.
No, I mean,
No,
I think we'll have to sort of see how these descriptions work out, and from there, I think one of the open questions is like, should this be a realistic execution algorithm? Something someone would actually implement, or are we fine defining something that can be used as part of satisfiability, but doesn't necessarily lead to like performant execution? So, for example, plan options, as it's used right now, only needs to take into account like a single path, right? We could just specify execution in terms of like finding a way to get the field that that path points to, and that would help us with satisfiability. It wouldn't help us with a realistic execution algorithm, where we would also need to describe like how we're building up a response, for instance, and how we want to like group fields into subqueries in some kind of optimal way.
Yeah,
yeah, it's also like in the execution, we also have to think about like reduction of downstream queries, for instance.
Well,
Like,
I think that's the question. Like, do we want to take that into account or not?
well, in my opinion, I would like to get in the middle ground between the two things, because we shouldn't be too specific in execution, because execution will be very, very different from implementation to implementation. But I still think that there should be a clear path how we get from an input query to an output result. So I think we need more than just plan options of a single path, because technically when we have a more complicated execution algorithm that can actually execute the query, we can also just do plan options, because this translates into a query. So we can say plan options, and then we just use the query planner for planning it, like we thought in the beginning. But I think there's a difference between making one path executable and actually figuring out how we want to execute.
Yeah, sorry, Shane. Go ahead.
I was just going to have a slight suggestion on a way that we could use as much as stuff as possible, reuse as much of the spec that we are defining as possible, which is in the simplest approach, you just do plain options for everything, and then you have some and that would output a plan for every single field. And then you can just perform some analysis after it. I think the complicated part is going to be like, obviously algorithms are trying to figure out as they do it and like figure out more than one option and figure out the best possible paths. To highlight your point, Michael, from before, like the big thing every implementation would want to do is to reduce the number of network requests. So like if you can see that like, oh, I did a plain options and on these 10 fields there in the query, and 5 of them actually are the same subgraph plan queries, right? Then like I don't make 5 queries to the same subgraph. I just merge those into one, right?
But
doing
even
something
that
is
is
just simple.
even that is just one constraint, right? Because you can also imagine sort of wanting to split up those fields differently because like a subset of the fields resolves more slowly than like the other subset, or you're caching a subset. So there could be other factors that sort of override the minimal amount of requests.
Yeah, and there's also another thing, like in a real world implementation, you also think about merging maybe parts of queries that you build up, and you see suddenly, okay, I can take them together, or I need to order them this way, and things like that. I don't think we have to go into these kinds of optimizations because also caching is out of scope.
I think. Oh no, definitely. But I think the question is, do we want to go into optimization at all? Like, should the goal of execution be to generate like some kind of optimal query plan, or should it generate a possible query plan or all possible query plans and leave it up to the implementation to decide between them?
I think that it would be fine if we honor satisfiability with the execution. So essentially, if something goes to execution, we also create a query, or it's also possible to execute this query. And I think that's the path we should go down. All the other optimization, like what algorithm do you use to make optimal network requests and whatever, what backtracking algorithms you use, and all these things could technically either be appendix, sub specification, or just blog posts. So
I would write a big note above both the satisfiability and the execution algorithms that they are exemplary, and that you probably have to exactly that is the GraphQL specification doing, right? Has this, you probably want to look in other side concerns like optimizing the query for the least amount of hops, or think about caching, or blah blah blah. We can have this as a big note over it, and then we just go for the first the first possible query plan that we can that we find. And this is not a good algorithm, but we kind of say that in the beginning, that it's for easy understandability. And I think if you have any algorithm to start on from a spec point, it is already helping people to figure out how this thing should work. In the end, the important thing is that the observable result is the same one that each gateway delivers, and not how.
Yeah, I agree. Like first of all, just to not get blocked too much on getting an execution, because the value is, you know, having something there, and second, yeah, as the criteria, it is correct and understandable.
Yeah, 100%. Yeah. And that's also why we shouldn't venture into optimization, because then it gets quickly either incorrect or
gets
not
very
understandable.
quickly.
Yeah. I don't know. I mean, what's the general feeling about when we say we want to do more than just plan options, then we will probably venture into a similar or go down a similar path that we have with satisfiability, where we essentially iterate over incoming not schema at the moment, but over incoming queries, and then try to write a generic algorithm how you get there, which is probably again some
Yeah,
Yeah.
so the execution
Double.
algorithm charters out the path how to get the data, but also it explains how to build up the basically downstream queries. But we don't have to take in all the complexities that we have in proper query planners.
Yeah.
So at a minimum, in terms of observable behavior, we need a result that like satisfies like spec compatible output. But in describing that structure, we'll probably also have to include fields that are not actually part of the query, but are, for instance, required by other subqueries, or either through like require or implicitly because of keys.
So we can use in the specification, we can use assert. So we can actually say that if we don't, like, let's say we need to resolve a requirement, or we need to that's what you mean.
Oh no, that doesn't
You want
work
the
with
result, but also the you want to observe the queries which are sent to the
Yes.
source schemas, so that you actually see that the requirement was included into the downstream request.
Yeah,
Well,
that-
what I'm saying is it's either part of the subqueries, or I mean maybe that's part of it, but also when you're describing sort of a result object being built up in this algorithm, like at a minimum, that result should include like everything the query specifies. But perhaps that like there's also sort of an intermediate result that is used by other subqueries. Maybe that's sort of we use the same structure for that. So we can say we sort of assert that the response object at this path has the required fields, for instance.
yeah. And then we can do like, yeah. Yeah, because it gets a bit messy there, because like but that's exactly what we did in the query, also the like how you inline the requirements,
Yeah.
and they become because that's a whole orchestration, like okay, we need to first get maybe this intermediary query, which we just do to a subgraph, to actually resolve the key to get to the next thing.
Yeah.
Yeah, and probably from an algorithmic perspective, we could. So the problem is a bit, you cannot be greedy, right? Because then you end up with a local maximum, and you may have a query that you cannot resolve. So you have to be not greedy. I mean, you can be greedy, but then it's much harder to specify, rather than when we just say each field is a possibility, and we just don't care about, from an algorithmic perspective, about memory and cost.
I wonder if we can sort of follow the normal GraphQL execution algorithm here, because that would also help us deal with like fragments and skip and include, and but basically, if we can say instead of a resolver call, what we're doing at this point is finding a way to fetch that field.
Yeah, but is it you just mean the traversal, like basically
Yeah.
Okay.
Yeah. Because we still have to deal with like fragments and abstract types and skip and include and all of these things.
Yeah, okay, you could yeah, that's a good remark, because like what we do before we do the planning in Fusion is we defragmentize and normalize the query. So we deal internally only with inline fragments, but not anymore with fragment spreads and stuff like that.
I believe we do the same thing, but I wonder if that should be part of the spec or not. Because if we're not going for sort of optimal,
yeah, but it becomes a lot more complex if you deal with fragments, huh?
Well, but it depends sort of whether you specify execution at the local level or not. Because if you just follow the normal GraphQL execution algorithm, by the time you get to like field resolution, you have inlined every fragment, and you even have like a concrete object type at that point, and you have resolved like the skip and includes.
Yeah.
The only thing is how do we? So we know after satisfiability, we know all the fields are resolvable somehow. So the question is, how do we avoid when we have 3 fields to have 3 queries? Because when you just use the spec algorithm, you get into the situation that you cannot go further because you're in this, local maximum,
Yeah.
or however you want to call it. You run into this error that you actually have to backtrack to then resolve the requirements and so on. And if possible, it would be nice if we could not specify backtracking, because that's super complicated to specify.
I don't.
What we don't have to worry about technically is memory. So we could also say that we just spawn out possibilities, then we don't have to backtrack. We just stop as soon as we are in a situation that we cannot do any.
Yeah, so this is what I mean. So getting to grouped fields, it would be nice if our algorithm can sort of start out from these grouped fields, like because that has already resolved fragments. And
Yeah,
Yeah,
we can reuse collect fields, I believe.
yeah, and you also have, of course, field ordering to worry about potentially, which just also resolves, like if the same field occurs in multiple places.
Do we?
Yeah, I just looked specifically also at this because this is how the core spec defragmentizes. They don't
Yeah.
do a front up defragmentization. They do it on a per field basis. So they basically say, I'm going in this selection set, which is here.
Yeah.
And then they go over all the fields in this selection set and defragmentize just this locally.
Yeah. So I wonder if we can sort of start out from the grouped fields. Like, what are we missing there? Or how can we regain sort of the non-local nature of building up a subquery?
Yeah, because it looks very simple. If like what we, for instance, do, the pre-processing of the document looks very simple, but as soon as you look at directives like skip and include that could be strewn across fields that should be merged, and then you cannot just merge directives. You have to do other stuff around that.
Yeah. And abstract types also
Yeah.
greatly complicate things. And
Exactly.
but yeah,
abstract types you have to resolve with collect fields before. So you pass in the object type, and then you get.
but that depends on knowing the object type. So you can't do it up front. You actually have to do it. Yeah.
Yeah.
But we could maybe reuse a lot of this algorithm.
Maybe we can reuse the whole thing. Like, what's the output of the algorithm? What do we get?
Grouped
The
fields.
group fields.
Yeah.
This guy. So basically, what it built up is a map with basically the field nodes in this case. So you have per response name a collection of fields that align to this group field.
Mm-hmm.
And the reason you have multiple is because you might actually encounter the same field multiple times, and they might have different sub-selections. But you only merge those at the next step.
Yeah, and also you can have competing. That's all. You can have competing directives. Like each of these fields could have different skip conditions.
Yeah.
And that defines if this field is even there or not. There are a couple of edge cases.
So I mean, this won't give you sort of a global optimal query plan, but it will give you something that works. And maybe that's what we're going for here.
Yeah, but what can still be difficult
Well, I mean, maybe
Is-
the thing here is that actually collect fields depends on runtime information, right? It depends on the object type, knowing the object type.
Well, that's not runtime information.
It is because the object type, like if the selection set is on it's on an abstract type,
Then you do it for all possible types.
Yeah,
not
but then you
not
have
according to this
constant type
algorithm.
explosions, and your tree could be very large.
Yeah.
Nice.
So one of the first prototypes of federation actually used this approach. It just used normal execution and sort of built up subqueries.
So you fetch as you go.
Yeah, fetch as you go, and that is the most simple approach, because then like when you've fetched a subquery result, you've built up a partial response, and then you also know, for instance, the object type.
Yeah, you can actually reference to the partial response that you have.
Yeah, exactly.
You can merge the fields, for example, requirements and so on. If you have to do an additional fetch to get required data, you can actually merge it into the result.
Yeah.
But it leads to an explosion in requests in the end.
I mean, there are
Or
more
could.
requests. Yeah, yeah. So it's not per field necessarily, but it is per selection set, I think, if you would follow this logic.
I mean, you have n requests per selection set, right? Depending
Yeah,
on-
but it could be
Why n?
because it could be that there's fields from two different source schemas in the same selection set. Then you have
Oh yeah, no, that might still happen. Yeah, but within one selection set, there should be only one request to one subgraph, I think, if you follow this.
Yeah.
Because you would go from grouped fields to subqueries, basically. Like the algorithm would take in grouped fields and output one or more subqueries.
Yeah. So that means we would do a request per nested. I mean, it hurts a bit to specify like this, but
Yeah, no, maybe there's a way to optimize it. Like we don't necessarily have to like fetch as soon as we've built up the selection set. Maybe we can,
well,
like if we don't
question-
need the information, maybe we can continue to build up the subquery.
So let me, because we keep running into this, but that's not great. Like conversation. So like, let's pause for a second. Let's say we implement some algorithm. Maybe it's this one. We specify in the spec. There's not going to be a reference implementation of this, right? So like,
No.
or like the reference implementation. So like what is the purpose of having this defined? Like someone would implement this to test to see that it produces a valid subgraph queries to say that we could execute it, but like is someone testing against this? Like what's the point of having that being like specified as like a spec
It
implementation?
describes how you can build up the observable result. Maybe not the optimal way, but like if you start with a new implementation, then it kind of gives you a quick start into it. And then you anyway have to overcome other things, right? But it describes it describes correctly how you can build up this observable result in the first place.
Yeah. I guess I'm just trying to get to the question. The root of the question I have is like,
why do we do this?
who would actually care and like why? Because like, if we prove that it's like if we proved like that the graph is satisfiable with the satisfiability algorithm, like why do we need to have a reference implementation that is like optimal at all? Like
I don't think we need a reference implementation
or a reference algorithm, I guess.
Well, I think the thing here is that when without an execution, without showing in the specification how you actually execute the composed graph, all of the meaning of the specification, like what does a requirement actually mean, is unclear.
not described.
So
It-
Yes. But do we need an algorithm to do that? Because if we show like, if at its core, what we would just need to show is that like, hey, like you can look at one field and run the staticity algorithm on it, and you'll get a query path. What we just need to describe is like this query path now might traverse multiple subgraphs. That's I think the problem we're trying to describe to people. It's like, how does one query path in the supergraph result in like multiple requests? Because that's ultimately what we're doing with against a network service supergraph. So we don't need to describe that in terms of like, this is the way when you have a complex query or a query that has multiple selection fields, this is how you combine the requests together. What we really just need to specify is like, you have one path, just one path to like one field. And that if you can say, this is how this could possibly be broken up into the n number of requests, then it would satisfy it. If we do that once, it doesn't need to be, we don't need to worry then about like, okay, and this is what you do when you have multiple fields, and this is what you do when like one request depends on the other. Like that's all an implementation detail. We just need to describe like, this is how you could then convert that into a runtime execution. And we don't worry about the details when you do it n times over. Like you figure that
Yes.
out.
So why it's a useful exercise is because of it describes how these features interact, like how requirement actually is done. For instance, when the Wundergraph people were in the meeting, they weren't aware of that you could have constants in the require. These kind of details are in the algorithm. And then you can basically say this is how requires works because it's described how requires builds up into queries, or that requirements can be in keys. Also something that people might not expect if we don't describe it in an algorithm. The second thing there is also features like provides don't play into satisfiability at all, but they are playing into the query planning, because they are optimizations of the query. So that's why it's useful to describe, even if it's not the most performant. I mean, the GraphQL core specification here, this algorithm is not performant. The field merging algorithm of the GraphQL spec is horrible. Like if you implement it like that, it's super slow in your execution engine. But it's there to be complete, like to describe the functionality. Kamil?
Yeah, so I wanted to say that like honestly, what I would do for the execution, I would completely ditch the idea of having like an algorithm, because at the very, very core, what you need is like a set of rules that you can validate if the gateway actually fulfills, and that's it. And if it does that, then the execution, like everyone can have their own, inefficient or efficient, doesn't really matter. But at the end of the day, the input should, you give it like an input, you have a black box, and then it gives you like the correct output, right? And that's pretty much what really matters. And this is like, if we, let's say, want to release like a auditing tool to check if your gateway is spec compliant, right? We don't necessarily check the execution or the algorithm or whatever. We just create like a, test cases that forces the gateway to do it this way and expect the output to be, matching this data pretty much. So I would like, for example, like instead of specifying the algorithm, what I would do is, let's say, I don't know, in order to execute this and that, you need to fulfill this, or like if you have require, then it has to go through the entity call and so on and so on. Also, if you have like an abstract type, what happens, this kind of stuff. And then based on those rules, you can build like, a very comprehensive query planning, or like, it doesn't have to be query planning because you don't need to plan really. It could be even stitching based. Like the query planning is just like what we would do, I guess, in a perfect scenario, but it's not required. So yeah. For satisfiability, yes, we need like an algorithm because, it will be super hard to actually to implement. But for the query planning, I don't know.
Yeah, that was
Shane?
going to be my suggestion as well. It's just like at its core, it's not an algorithm. It's just to define rules of, as you said, Michael, like there are complicated edge cases with requires and the keys selections. And so like we just need to say like if you had one query that depended upon those things and you had to go fetch it, like this would be your requirements as you're going to call those things. So it doesn't need to be an algorithm. It's like you just need to specify that for every single feature that we have. You need to specify all the rules, and like the algorithm is like go run all the rules. I don't know. Like we could keep it even simpler than this, and like not worry about the HB requests bundling and all the things.
Pascal?
Yeah, so one benefit of using or abusing plan options or reusing plan options is that the whole thing about collect fields and so on, we don't really have to worry about, because we know that at any point in the algorithm, we only care about one specific field. And the output could technically be that we say not only what source schemas are involved, but also what queries that we generate. So then we could technically have one algorithm which covers everything, including provides, requires, and so on. But from a simplicity perspective, the algorithm runs only with one field at a time. Michael is running tests.
Ha!
Yeah, so we could do it this way. Then we would simplify the algorithm to the whole result composition and all of these things we would essentially get rid of. And we would just say that when we plan options with the requirement, we expect this output. That would make things probably easier. And regarding the result, we could technically also say that, I mean, a lot of the result structure is actually given by the graphical specification anyway, so that you have to have the fields in order and whatever. So that could just be a reference to it. Like we can just say that in the actual execution chapter is this is how plan options work. This is how we resolve provides. This is how we resolve requirements. This is how we think about this and that and whatever. And then you also have to make sure that a request is valid in terms of the graphical specification. And then the whole execution algorithm, the complexity of collect fields and building a result and merging requests and all these kind of things would just be gone.
So if we're fine with basically an approach like plan options, where we only plan a single path, so basically a single field, could we make all of this resolver based? Could we simply plug into the standard graphical execution algorithm?
Well, my point is
because that would be just as inefficient.
Yeah, but the point being here is if we just discussed about the collect fields and whatever, and that we most likely would end up with one request per selection set, and then we could optimize it with a bit of greediness that we try to resolve as much as possible while we are on a subgraph and so on and yada yada yada. But in the end, you end up with something in the specification which we all know is not good for production.
Yeah.
If we say, like, think about it, you read the specification and everything makes sense. Then you come to the execution chapter, and then you read, they create 50,000 requests for one query. Then you probably give up hope. But when in the execution, it's just written like, these are the rules for execution. It's up to you how you exactly do it. Options are you can do it resolver based with a simple example, without algorithm. Just you can do it with
Yeah.
solver based. You can do it with a query plan. You can do it however you want. But essentially, all the algorithms have to follow these principles that the requirement is resolved in this way, provides is resolved in this way, and so on. Because then
And the results have to follow the graph core specification, like value completion and blah, blah, blah.
yeah, because when we specify it in an algorithm, we end up with something which is not good. Like we would never implement it like this. Like the Apollo gateway, the Guild gateway, and the Hot Chocolate gateway, we all do the same thing. We get a query, we plan how we want to execute the query, we reuse this plan because it's inefficient to do this all on always in the request, and we also don't do it resolver based because we all ran into the same issues. If we do it this way, then we run into inefficiency because we do too many requests. So does it make sense? And now I'm a bit siding with Shane here. Does it make sense to specify something where we know that it's not good? Like if you read it and if you read the specification and you come to this chapter and you're just like, well, that's never going to perform when you look at it, then the question is what this makes you feel like, right? Rather than there is sufficient implementations of it. You just have to come up with a solution to solve this set of problems, right?
So if that's the case, would it be helpful to just start the process with trying to specify plan options? And then we'll have a better idea of sort of what that takes, and whether it makes sense to extend that to an actual execution description.
Most likely. If we go down this path, then yes, plan options would be the next thing to specify. And plan options would be part of the execution chapter. It would not be part of the satisfiability chapter. It would just reference it from the satisfiability chapter. And in the execution, we would then describe what plan options does, right? And we also have to think about what's the artifact that we get out of a plan options. Like it cannot only be the source schemas that are involved in the end, right?
Yeah. Yeah, I think the way we described the outcome here is that the outcome of satisfiability, I mean, is that we want to show that every valid query against the API schema, we're able to execute that with a set of subqueries to the subgraphs or something. I don't remember the exact wording, but so if we're doing that field by field, that's fine. But we still need to describe sort of what subqueries will have to be made to resolve that field.
And then we probably the implementation will be similar but still different to the satisfiability algorithm, because we run into exactly the same thing, right? We need to track what options we have when we visit this query segment, and we need to plan on a by field basis probably. So it's always you're in one field and you have to find out what's next.
Yeah.
We have multiple options. So
yeah.
So the plan options that we specify would deal with requirements, right? And it would
Yes.
Yeah.
But where would we deal with things like just optimizations like provides?
Well,
because I'm just saying that because like for satisfiability, provides is irrelevant, so it's not relevant.
But
well, it's still an option. Like if we're generating the options, like the provides generates an option.
like the schema has to be satisfiable without provides, but technically we can still plan with provides. Like if you have multiple options, one of the options can be a valid path through provides. Like you're on username, one valid path to this could be through a field that has provides name on it. That could be an option.
Yeah, but it could lead to schemas that are only valid if there's provides in it.
Well, we can just say that we remove these options for satisfiability. We plan with it, but for satisfiability, all the provides option.
I ignored.
Or actually, like if every possible path goes through a provides, that may be fine. Like if it doesn't lead to a situation where we can't resolve the field, like maybe there are like two provides paths. Like you can get the username because it's part of a post or because it's part of an account or something.
Yeah, if the to your point, Michael, if something is only valid through provides, that's not a bad thing. Like that's still satisfiable. Like that's still valid. Like
yes, but like the premises is that we had is that you could leave that you switch essentially provides off, and this satisfiability is what counts for the satisfiability algorithm, right? Because otherwise it could be you could create very complex. Yeah, I mean it's a user problem at the end because the schemas, if they are only valid because of an optimization, it could be very difficult to see.
I mean, we can also remove it. Like we can remove the restriction that if it's only satisfiable. Like if we think about it, it's fine. Like if you have a schema which is resolvable only because the right provides annotation, it's fine. We can just remove the restriction and work with it. It's very unlikely that you get into this situation, I believe. But
in terms of the spec algorithm, like provides isn't an optimization. It's a path defining thing, right? It's saying you can also take this path. Like it might be shorter, it might be longer. I don't know. It doesn't matter. But like you can also come to this path. And as long as there's one path, then it's good, right? And so I agree, like this probably doesn't have to go in the spec, but this is something like in Apollo docs, we would say, be aware of this. Like if this is something that's going on in your supergraph or something. But like in terms of an algorithm, like it's totally fine to say the only way, like you specified a field over here in this subgraph, but it's technically not accessible. It's only accessible if you go around and get to this provides and then go through this other stuff. That's still good. That's still okay. That's still valid. And if we remove the provides directive, and if we don't consider it and we can't find a path to that field, then it's no longer valid. So I think we do have to consider provides and the key selection and all this stuff when we're doing plain options. Like those are inputs to say these are how you can traverse the graph.
Yeah, important is like in the end, important is that it's consistent. If we describe the algorithms with provides, then this is like two subgraphs that ran in Apollo and were satisfiable with provides must also be like when you move from gateway to gateway, they must be satisfiable in the same way.
Yeah.
So we need to be very clear that either provides is part of satisfiability or not. And if it's part of satisfiability, then it must be across platforms.
How would you end up in the situation when a field is only resolvable through provides anyway? Do you miss keys to move between source schemas?
I think that would be a possible case. Yeah. If there's no way to get from like the root to a certain type that there is through some kind of path. Or
but
maybe
you could end up very, very easily with that, right?
Yeah, but
a certain path.
There's another field that will fail. So let's say you have author which provides name. Name is the only field on the subgraph because you already have it in your database because you have duplicated data.
Mhm.
Now you don't have an ID, so you cannot move away from this.
The problem is when you now take it somewhere else away, but it still works because you have this optimization on this subgraph.
Yeah, my point is that name would be satisfiable through provides, but any other field in the same selection set, any other possible field in the same selection set would not be satisfiable. Like, let's say user has ID, name, and description, whatever. And
Yeah, Pascal, but it's not on a field basis. You could have a huge chunk of data that is that you have in provides.
yeah, I mean, I'm not saying, I'm just saying that, is there a way to get, like what's the issue, right?
I think we're now getting to the point where we're discovering things that we need to figure out in the rules, and we probably need to write them down to figure it out. But
Yeah.
it sounds like we agree that if we can describe things in terms of satisfiability and like the features that you would need to do that, this is essentially the planner and plan options. So if we can just go through those rules and then say, okay, for keys and key selection, you need to consider these, and we write the rules down. And we're going to get to provides, and we're going to have to write those down. And I think when we start writing them down, we'll probably figure out the intricacies here. And then it'll also help us figure out like what are there any directives that are not taking into account in satisfiability? Like I guess the require, not requires, but like require, maybe. I don't know. But like what are those directives that go into satisfiability and what are not, and what are actual
Yeah, require is a
optimizations?
must because
Mhm,
without
yeah.
require you can like this is this is actually why you need satisfiability, right?
Yeah. I guess my point is if there's any optimization directives, which I'm trying to think which there actually probably isn't at this point, they would be in the planner, right? Not in the satisfiability per se. Or they could help, like provides helps potentially, but it's like still needs to be considered in terms of satisfiability.
Stephen?
Just I guess I'd put out this out there as an opinion, but I do see how provides it does change the path. We considered it, we could consider that as like it probably is possible to have a graph that is only satisfiable with provides, but uh I I do like the idea of having the base satisfiability not included because I think that the intent of provides is as kind of an optimization, type of feature that should be optional. And so personally, I like the idea of omitting it for satisfiability.
Yeah.
I mean, we can trust track and plan options that this path would only be satisfiable through provides. We need to come up with an example when this could happen, which is tricky. But
What could happen?
I don't
Pascal?
think it's tricky at all.
No.
If you don't have a root field, for instance, that resolves user, but you do have a path through post that goes to user and that provides like all the fields in the user. Let's say it's just name. um, then I think that would already be a case, right?
But the question is, do you need, I mean, that would work without provides as well. Like you could
No. But I'm saying there's no like let's say post doesn't actually have the ID, for instance,
Mhm.
or it has like it doesn't have a key that allows it to jump to the user graph.
Yep.
But you still provide all the fields of user.
But if you provide all the fields of user, you also have the key, right?
Um,
No, it's like Pascal, we have a couple of test cases for that. Like
I don't,
it's very
I don't
easy
think it even
that
needs to have a key.
it's very easy that you can run into this.
Okay.
So, and I'm also like, my feeling is we should define it without provide satisfiability.
Because it's probably a mistake if your graph is only satisfiable with provide.
I think
you
we
probably didn't
can
mean to do that.
we can make that decision, but plan options still needs to take provides into account.
Yeah,
Because we need to describe it at least once in the spec, like what the meaning of provides is, and it is an option. We would just say that for satisfiability, it's an option we don't take into account.
Exactly. So we either have a parameter on plan options that we want to disable provides, or the output of provide says that this option is only valid through a provided path.
Yeah.
Okay.
I think we're getting somewhere.
slowly.
Yes,
Yep.
this is the planner, right? And this is the difference between a planner and satisfiability. It's like it's the same algorithm, but the input is like turn on optimizations. And it's like if you're not doing optimizations, then don't do this feature set. Otherwise, if you're doing validation, run these rules. Like that is essentially
Okay, we are also at time. So let's continue the discussion next week.
Sounds good. Another 15 minutes.
Again,
Yeah.
another 15 minutes next week.
Yeah.
Okay.
Okay, cool.
Have
All
a
right.
nice Easter holidays.
Yeah.
And
Yeah.
Uh,
Happy Easter.
See
you
you
next
next
week.
week.
Easter.
See you. Bye bye.